Okay, so the video for this week, there's only going to be one that we have to watch, and hopefully it won't be too long. But we're going to move on to choosing between all of our inference methods. Okay, so when we took tests before, we always narrow it down. We only have specific ones that we're working with. Now we're going to have to be able to evaluate a question, and then decide what parts of that question lead you to what type of test or interval to create. Okay. Now, number one is the oddball, so I'm actually going to skip to number two, and we'll come back and hit number one in a little bit. In October 2010, the Gallup poll asked 510 randomly sampled adults the question, generally speaking, do you believe in the death penalty is applied fairly or unfairly in this country today? Of these, 58 of these, 58% responded fairly. What can we conclude about the opinions of all adults? So it's asking me to estimate. Okay, what is the true proportion of adults? So therefore, since we are estimating, that means I am going to conduct an interval of some kind. Okay, now, since it's an interval of some kind, I have to figure out is what kind of interval? Meaning, does it come from a proportion, and that tells me z, or does it come from a means, which tells me t? So this strictly comes from a proportion. So therefore, a proportion equal is going to indicate a z interval. Okay. So because I have one sample, okay, and I'm going to conduct a z, and it's going to be an interval. So this is going to be a z interval for proportions. So this is going to be b. Okay. And that's where we need to go. Now, if you want to, you can print out we made a little flow chart for you, and you can figure out if this flow chart is something that might help you get to what answer, get to the right interval or test that you need to do. Okay, so here in this flow chart, we would go like this. We were making an inference. We're talking about the proportion of people that felt like the death penalty was fair, so that means we're dealing with a proportion. In that proportion, was there one sample or two samples? Well, I only had one sample to go off of. And then lastly, did they ask me to estimate, or did they want me to make a decision? Was there enough evidence? In that last case, they wanted to ask me to estimate, and therefore that led me to the z interval. Okay. Now the only thing I don't like about if you don't have the chart handy in front of your face, then this really makes it this could be crushed very, very quickly. But however, you will have open notes on the AP exam, so maybe this year it wouldn't be so bad. So if we can learn a way to do it with necessarily out this, that will be helpful. But we'll keep pulling that document back in just to help us through this. Okay. A cruise line is trying to determine if there is a difference in the mean amount of money passengers spend on board their ships during a one-week cruise to Alaska and a one-week cruise to Mexico. A random sample of 35 passengers is taken from the Alaskan cruise, and a random sample of 30 passengers is taken from the Mexican cruise. Is there a significant difference between the mean amount spent by passengers? Okay. Now, how I like to start it is, I'm going to go back to the question. The question is there a significant difference? So that means I'm answering this yes or no. So that means this is going to be a test of some kind. Okay. And now that I've evaluated it as a test, I'm going to go see what type of test it was. We're talking about the mean amount of money. So the variable that I'm working with here is that mean amount of money. So since it's a mean, that means I'm going to use a t test for this. And now I need to determine how many samples were there. Well, I had a random sample of Alaskan cruise and another random sample taken from the Mexican cruise. So I have two samples here. So that means this is going to be a two-sample t test. Okay, and hopefully we'll look up here and we'll find that a two-sample t-test is I, and that is it. Okay, so we are trying to glean pieces of information from what I'm reading out, what we read through, to help me decide what to do. Okay, let's try to do number 4. Okay, in number 4 we have the National Center for Education Statistics monitors many aspects of elementary and secondary education. In 1996, numbers often used as a baseline to assess changes. In 1996, 31% of students reported that their mothers had graduated from college. In 2000, Responses from 8,268 randomly chosen students found that this figure had grown to 32%. What is the change in education level among mothers? So the question is, what is the change? So because they're asking me to estimate what the change is, this question leads to an interval. Okay, I know that I'm going to create an interval because they asked me to estimate the change. And now I have to figure out what type of interval it is asking me for. Okay, so it said in 1996 we had 31% of the students reported their mothers. In 2000 we talked about 32%. Okay, now this one's a little bit hard just because it didn't give me any. Their 1996 numbers didn't give me a count, but really this came from 1996 and it came from 2000. So that means that I have two samples in there, and I'm getting way off here. Usually I start with my what type of variable is it? It's a categorical variable because it's percents. Okay, so that means because it's percents, we're going to be doing a z interval because of the percents. And it came from two samples. So this is going to be my two sample z interval. Now, because z intervals can be used if we know the mean the standard deviation of the population, that could lead us to a z interval for means, but however, we just don't see that, so we left that out of here. So anyway, this is going to be D. Okay, D. I'm going to go back up to number one and do it, just because it's going to be, I don't want to say the weird one, but it's the one that kind of stands out, because if we go through that question, what question does it ask me? This kind of goes the other way. A golf instructor is interested in how much improvement individual beginner golf class students made of a course of a 4-week clinic she teaches each summer. Before the clinic began, each golfer played all 18 holes of the course before the round was given. The same was done when the players completed the clinic. Okay, so we are looking at the scores. The score is the variable that we're doing here, and we're wanting to know how much improvement. Now, how much improvement tends to lead me to an interval. Okay, however, because the same was done when the player completed the clinic, this was a before and after. Okay, this is going to be a matched pairs situation because we did before and after. So really we want to see if my score is going to be less than 0 when I find those differences. So this is actually going to go a little bit different. That went with E. It's our matched pairs t-test. Okay, that one's a little bit quirky. Okay, so there are 5 left. Here's what I'd like you to do. What I'd like you to do would be pause the video. And I would like you to see if you can do 5, 6, 7, 8, and 9 and give it a shot and see how you do. But if not, I'm going to carry on, and whether you pause me or not, here's the rest of the answers. Okay, at North High School, the average number of cars owned by a family is 2.35. At South High School is a more affluent area of town, and students claim they have on average more cars per family. A simple random sample of 36 students at South was selected, and they were asked how many cars were in each family. Okay, so again, it's a case of it's a what's our question? Okay, at North High, where's the question at? They believe there are more affluent. The students claim they have more cars per family, so they're not. We're studying a claim. Okay, claim they have on average more cars. So because we're studying a claim, that's going to mean we're going to. That's a yes or no question. So that means this is going to be a test. Okay, the test comes from how many samples we had here. Okay, what do we have here? We had a simple random sample of 36 students from South High School, but we didn't have a random sample at North. We just had a known value from North, so we only had one sample. And because we're talking about, again, the average number of cars, and I'm kind of mixing it. I should keep the order the same each time. That's going to make this a t-test, okay? And we had one sample. So this should be our one sample t-test, and that is H. Okay? Now, real fast, I forgot I was going to do this document here, just because sometimes I think it helps us to roll through this, and maybe some of you have or haven't done this. In this particular, we are making an inference. We're talking about the average number of vehicles at a school, so that means it's an average. So that means it was a means, or it had quantitative variables. When you go to do your homework document, it's going to ask you whether it was quantitative or categorical, which is the same thing as means or proportions. Okay. From this, did we have one sample? Was it paired samples or was it two samples? Okay. In this case, we were talking about one sample because we just had the one sample from South, and they're asking me, is there a difference? So that means it's going to be a test. So that means we have a one sample t-test. Okay. Let's do the next one. I'm sorry, I should have brought that document in on my others. 6. An occupational safety administrator is interested in reducing repetitive motion injuries for office workers who use computers. The administrator divides 48 volunteers randomly into two groups. The first group will use a standard keyboard for 12 months. The second group will use the new keyboard designed for the same period. At the end of the study, frequencies of the volunteers experiencing repetitive motion injuries with respect will be compared. All right, so we're going to compare their frequencies, and again, you're going to ask us, what is it? Is there a difference? Okay, so yes or no, is there a difference between the two groups? So that means this is going to be a test. Is there a difference? Okay, is this going to be a t-test or a t-test? Okay, we're talking about we come back up here, we're going to study the frequencies or proportions. So since it's going to be a proportion, that means that we're going to do a z-test. And we had 48 volunteers that were divided into two groups. So that means this is going to be a two-sample z-test for proportions. So this answer is going to be G. And number 7. Up here, forgot. I was going to walk through this each time, what I meant to do at the beginning. Okay, again, we have the occupational. We were talking about proportions. We're talking about the proportion of people that have the motion injury, repetitive motion injury. Okay, that proportion came from two samples, one that used a standard keyboard and one that did not. They did not ask me to estimate the difference. They just wanted to ask me, is there a difference? So that's a test. And so that's the two-prop Z test. Okay, or two-sample or two-prop. We got to have that in there. Okay, for the best answer. We need to have that proportion thing in there. I'm not doing a very good job today. We'll try. Hopefully we'll get. I've only got through enough to get better, so we'll try. A company is willing to renew its advertising contract with a local radio station. With only if the radio station can prove that more than 20% of the residents in the city have heard and recognized the company's product. The radio station conducts a random sample of 400 people and finds that 78 have heard and recognized. Is there enough evidence for the company to continue to advertise on the radio station? Okay, so the question is this enough evidence? Okay, so because this is enough evidence, that means that we're going to conduct a test. Is this going to be a z-test or a z-test? Right? T-test or z-test? I think I said z-test twice. Wow. You think this is late at night or something? Okay. Anyway, we're talking about we want 20% of the residents. So since we're talking about a proportion of recognized, we're talking about a z-test for proportions. And now we have to talk about how many samples it had. It came from, it looks like we have a random phone survey of 400 people. It was one sample. So we have a one sample z-test for proportions. So if we go up above and look, hopefully you wrote down an F. Okay. Again, if we take to our chart here that leads me to the right area. We're making an inference. Okay. This is about the proportion of people that recognize the jingle and the product. Okay. It came from one sample. They're asking me to, is this enough evidence? So that means it was a test, and so that was our z-test. Okay, our z-test for proportions. All right, is this showing up? That's showing up. All right, there's enough space here. The housing market is in a downturn in Dotyville, in a large community. A large community. Now, why does it say large community? Again, if my sample size is too large, then they can't be independent. So that helps us realize that my sample size will be okay because they came from a large community. Anyway, that was a side note. Readers look to estimate the average home value loss randomly sampled 36 bids. I can't read today either. 36 bids from potential buyers. Here we go. We are going to estimate something. So since we're going to estimate something, that means we are going to construct an interval. Okay? What are we going to construct an interval on? A mean or proportion to estimate, and we're talking about the average home value. So that means it's going to be a t-interval, and we'll stick means behind it, but that's kind of repetitive. And now I need to know how many samples did this come from. So this came from one sample. So a one sample t interval. So and really there was no one sample. It was just a above. It was a t sample, a t interval for means. And our last one, in an experiment comparing. Oops, here I forgot. Here it is. Okay, what are we making an inference about? In this case, we were doing the average decrease in home value. So that was a means. This came from one sample. They asked me to estimate the change. So that means that's why this was a t interval. Now that you can't see that, there we go. It was a t interval. So again, this is the chart makes it kind of seem easy, but our goal is to be able to identify it without a chart. In an experiment comparing the pinch strength of patients 4 weeks after surgery for carpal tunnel syndrome, found patients having the endoscopic procedure was 9.1 kilograms to open incision of 7.6 kilograms. What is the estimated difference between the two? All right, so again, what we wanted to be estimated difference. So they're asking me to estimate a difference, so that means we're going to estimate an interval. Now, process of elimination says we only got one left, but we're going to still talk through it like we have been. Okay. We're talking about comparing the pinch strength patients to carpal tunnel. Evidently, it doesn't say average, but that's got to mean an average. Okay, so we're talking about an average. So that means we're doing a t-interval, and we're talking about means. And we had a sample of patients that had the endoscopic surgery and another sample that had the open incision surgery. So this was a two-sample. And I think up above, if we look for two-sample t-interval for means, that would match up with letter C. Okay? If we come over and use our handy-dandy flowchart, we were talking about the difference between grip strengths. So that would be a means because it was a quantitative variable. We had two samples, okay? We'd had to match them on age and previous strength in the hand and health and gender and all that fun stuff if we're going to do match pairs. But anyway, we had the two samples, and they wanted me to estimate the difference, and so that came to our two-sample t-interval, which we decided what it was. Okay? All right, now, real fast, just to talk about your homework, because your homework is going to look like this. It actually comes from old free response questions from the AP exam. Okay, so if you get a chance to copy that, if you had a chance beforehand to copy that off, I'm not going to walk through it, but I'll just talk about how it's different. So they gave us the text of the problem. And here's the question: is there evidence that the mean mental skill score of babies who use walkers is different from the mental skill score of babies who do not do that? So, in this particular case, because if they are asking me, what are they asking me? They're asking me a test question, right? Is there a difference? So that's a yes or no. So this will be a test. But if you walk through how Nimsy wanted you to do it, basically it was walking through that flow chart. Is this categorical or quantitative? Okay. And if we look up here, it says a question asking for descriptive statistics should answer a means or a proportion. But because this is quantitative, okay, this is quantitative data. What are the categories of the units? That means grip strength. Okay, excuse me. I'm on the last problem. This is our mental skills score. here's where our descriptive statistic is. Again, because we're doing average, this is going to be a means. How many samples did we have? Well, we had babies who used walkers and babies who did not use walkers, so there's 2. So that means this is a 2-sample t-test. Okay, but there we go. So what's going to happen is we have this assignment. I would like to look at it Wednesday, and again, I really struggled on seeing your documents as far as logging into. I mean, actually, no, you can still do that. If you want to log into my my session, just log in and show me. Or you can shoot pictures and attach it. I will put a homework assignment in Canvas. But we should be having a quiz over method selection around Thursday, and then we're going to have a mixed hypothesis review, which is going to link to that quiz as far as going to reuse the same problems. So we need to get that made. But that's all actually I'm going to talk. That's the only lecture to have this week. There's 20 minutes. So, all right, have a great day.